Understanding the concept of referencing and dereferencing is very important. So the next section we'll have to look at is pointers. What's a pointer? When a variable's memory location data field can store memory addresses values, it's called a pointer. Let's define another variable I'm going to call p, or yes, p. And this p variable has now a memory location assigned to it, and then a data field for this memory location. As we said, the p variable, a pointer, is a variable where the data fields can store memory addresses. So a pointer is simply a variable. The term pointer is just a term to designate these kind of situations. Let's go back in the code. I'm going to define a variable named p. And then, since the data field of the memory location for that variable can store addresses, memory addresses, we call it, we add a star sign in front of the name. The type of the memory addresses or the type of data stored in those memory addresses are is int. So this simple notation tells the compiler that we define a p variable that represent a memory location, and the type of data it can store is um, is of is of is an address. Now we add in the star sign to tell that to the compiler. The next thing is the type of the memory location. Um, I can say the type of the address or the type of data the memory location can store. For example, we can assign to the variable p the address for the memory location represented by the variable age. We tell the compiler with the ampersand sign, then age, the name of the variable. The compiler return the address of the memory location represented by age, and this value will be assigned to the data field of the variable of the memory location the variable p represent. On the right side, you can see here we'll have the type of data will be of type int start, and the value stored in it is, let's say, 0x f05 f5w, or let's say no, a8f5ze, for example. So this is an address, let's say the address of the memory location the variable age represents. We can now say that p point to age because p store a reference or an address for the variable age or for the memory location age represent. Let's type in something. I'm going to update the value of age. Let's say age equal 10, then display its value. This is the first or the simplest notation. Now there is a second notation. We can use referencing and dereferencing. Now I tell the compiler I want to get the address of the variable age or the memory address. Then use the dereferencing operator on that value on the requested address using the star sign. And next, we can also display the value of the variable age by just typing the dereferencing operator in front of the pointer name. So since typing P tells the compiler to return the value stored in the memory location, so it's going to return the value which is the actual address of age. Then typing the dereferencing operator tells the compiler to get the value from the memory location which has this address. Let's compile and run this code. As you can see, all these statements print 10, 10, 10. So we can store the address of a variable into another variable, meaning into another memory location. The data field that can store an address, or let's say the memory location that can store an address can be called as a pointer because we can use that memory location to refer back to the original memory location it is pointing to. So this is all about pointers. There is no magic here. Next, what if we want to create a variable that can store an address for the variable P or for memory locations that has a data type which can store integer memory location addresses? Let's say we define an X variable and the X variable has represent a memory location and the memory location can store addresses for memory addresses, or let's say for memory locations that can store addresses for other memory locations that can store integer data type. So this is a pointer to a pointer. We can type in the star sign to tell that this is pointing to a pointer, and the data type will be int for so the data type will be a pointer to a pointer of an integer. Now, how to declare the X variable? We can declare the X variable like that, X, then we type in the star sign to tell the compiler that the X variable represents a memory location that can store addresses for other memory locations. Now the next step is we type in another star sign to tell the compiler that this variable store an address for other memory location that also can store addresses for other memory locations. Then we type in, for example, you can add in as many star sign as you want. Just follow the logic. Now I'm going to type in int. Now we're telling the compiler that the variable X represents a memory location that can store an address for other memory location that can store an address for other memory location that store integer data type. Now, what is one of these variables that can store an address for uh, other memory location which store data, an integer data type, the p variable. We can do something like that. X equal the address of p. This tells the compiler we want to assign the address of the variable p to the to x. For example, if the address of the memory location p represent is, for example, 0xFFFFY B, then on the right side, let's type in something like 0xFFFFB. So as you can see, this is also a memory address. Defining the data type for the memory address tells the compiler how to use the variable x. So these are rules the compiler is following. Now let's go on the next step. If we're able to use dereferencing, we can, I want to say, if we want to use dereferencing to read the value of stored in the address or P, we can use the same dereferencing again to read the value for the variable age. Let's do that again. I'm going to type in printf, then the percent sign D, then type in the dereferencing operator sign, or let's say the X variable. So when you type in the X variable name, this will tell the compiler we want to get the value or the data stored in the X memory location, which is the 0, for example, the 0xFFFBEA. Now I want to use the dereferencing operator to tell the compiler. Now I want to look for the address or the, no, let's say I want you to look for the memory location that has this 0xFFFBEA address. The memory location will be the memory location represented by P. So the start X will return 0xF5A8F5ZE. Let's say CE. You can add another dereferencing operator, the start sign. This will tell the compiler again, okay, you have this value or this data. I want to look again. I want you to look for a memory location that has this address. So it will look into the memory. Then the memory location would be the memory location represented by the variable age. Then the value stored in there is an integer data type, and this is one header. In the code, I'm going to update the assignment to the variable age to see what's going to happen. Now, all these lines should display one header, one header, one header, one header. Let's compile the code, GCC, the start sign C, then the output program file name would be program. As we see that the first display one header, the first line here, the first printf line display one header, the second line displays one header, the third line one header, and the fourth line one header. So dereferencing and referencing is no magic. All variables are simply representing memory locations. And depending on the type of data that memory location support, we can define the type of the variable. So this is all about pointers. Pointers are simply simple variables that also can store data. Now, what's about functions? How values are passed down to functions.